Okay, so today we're going to do a new topic, linear functions. And graphing linear functions is the first part. And linear means a straight line. So it's not curved like a parabola, will be like curved one. Whereas a linear equations, linear functions, all those ones is a straight line on the number plane. Okay, just want you to have a look at this number machine here. Okay, the one that is here right now. What does that really mean? It just say this is the box is like in your head, okay, and that has the process, the function. In this case, y equals 3x minus 2 in there. Pardon me. And if I put x equals 5 into this box, which is only going to go into that where x is. Okay, so that means 3 times 5 minus 2. And what will come out of is y equals. So in here, in your head, you're doing 3 times 5 minus 2, which is 15, take away 2, which is 13. That's all that was. Nothing special. So input is the x equals 5, and then output, your product, is y equals 13. More important stuff is here, gradient and y-intercept, guys. Okay, the gradient is a measure of its stiffness, how stiff it is. And then y-intercept is the one that is on the y-axis when x equals 0. Hopefully you remember that one. And the gradient of a line is rise of a run. And the little m is our symbol here. So this is the one I'm talking about right now. Okay, so rise of a run. So this like a cyclist is going uphill. And if you think about it, your rise is something in a y value, isn't it? Yeah, so that's a y value. Okay, rise is y value. Run is something to do with x. So when we say gradient, rise of a run, change of y values and x. Okay, so just want to give you a little bit of heads up on that one. So example 1, I'm just going to do substitution. That's what I'm going to do. So to answer all these y values when x values are minus 1, 0, 1, 2, 3, what I'm going to do is I'm going to put y equals 3, x is minus 1 in this case, minus 2. So that's when x equals minus 1. Okay, so we're going to use this equation, y equals 3x minus 2. It's not a just equation, it's a linear function, linear equation. So when we do that, it's minus 3 minus 2, so it's minus 5. So my answer here is minus 5. Okay, and then when x is 0, y equals 3 times 0 minus 2. That means it's 0 minus 2. So I'm going to write minus 2 right there. And then when x value is 1, y equals 3, 1 minus 2. So that's 3 minus 2 equals 1. So that's what we did, okay? Hopefully, the more you practice, this process will become quicker and accurate. Okay, so now part B. What pattern do you notice in the y values in the bottom row of the completed table? So I'm looking at right here, these ones. So what happens from here to here, here to here, here to here, here to here? That's what the part B is asking here, right here. What pattern can you see with the y values? Now with the negatives, we're a bit hard to tell, but if you look at the positive values, 1 becomes 4, 4 becomes 7. It looks like it's going up by 3, isn't it? So by 3, up by 3. Now, I want to make sure that's the actual correct pattern. So use your calculator when it's a negative values, okay? So when you put -5 plus 3, will I get -2? Yes, you will. So that is correct. And when you do -2 plus 3, will I get 1? Yes. So what I'm going to say, the y values, I'll just say the y values increase by 3. That's all. That's all that is. Now we need to graph it. Okay, so how am I going to graph it? I'm going to use the gradient. Okay, I'm going to use the gradient. Before I do it, I'll probably have to scale it. So I'm going to go with 7 to go down. So I'm going to use red, 7. So make sure you use grid paper for all this graphing things here. 0, -1, -2, -3. Okay, probably need a bit more. So, okay, so from the table, I remember, I'm going to just write it here. When 1, it was -5. I knew that was going to be 5 there. Never mind, I should start with a bit higher. And 0 and 2 and 1 and 1, 1, no, 2, 2, 4, and 3 and 7. Okay, so what I'm going to do here is just imagine there is a -5 down here. Okay, I should have sketched a little bit higher up there, but I'm just going to put -5 there. Okay, so 1 and -5. No, I'm wrong. It's a -1. So I have to go with -1 and -5 right there. Okay, -2. So 0 and -2 here. And then 1 and 1. I think 1 and 1 is correct. And then 2 and 4 is here. And 3 and 7 is right there. So when I sketch all that and join them, I'll show you the final product. But I want you to have a look at this. This is actually y equals 3x minus 2. Okay, so your gradient, this is like sort of rise over run's gradient, and that's Y-intercept. So you know it's definitely going to go through -2. That's why when I saw it, I knew I made a mistake there, because it has to go through -2. Rise over run, it doesn't look like a rise over run, isn't it? But if I put it into over 1, that's my rise, that's my run. So if I look at this, now if I sort of join this, right, and then make it rise over run, do you remember the cyclist going up and down? That's my rise, isn't it? The triangle, and that's my run. Okay, each of these will have this rise over run. Now look at this. Rise is 1, 2, 3. That's my rise, 3 right there. And run is 1. Okay, it will be looking like this. Okay, so that's 3 and 1. So my rise is 3, my run is 1. And every single one of them is the same. And that -2 is my y-intercept. You probably remember working on this sort of thing. So here it's y equals mx plus c. M is the symbol for gradient, and c is for y-intercept. And with that equation we had, y equals 3x minus 2. 3 is my gradient, -2 is y-intercept. It's not just 2, -2. Why? Because here it says plus c. So we have to include -2 as our y-intercept. So Next one, example 2, I'm going to do. Now, example 2 here, we do A first. And just like what we did before with example 1, I'm just going to put it in when x equals minus 1. I will go y equals minus 2 minus 1 plus 4. So that gives it minus times minus becomes 2 plus 4 equals 6. So I'm going to put it as a 6. I'm going to leave it up to you to do it. Okay, so I'm going to just write the answers here. It should be 4, should be 2, 0, minus 2. So if you do that, that's what I'm going to get. And when you look at this, 6 to 4, 4 to 2, 2 to 0, 0 to minus 2. It's going down by 2, isn't it? 2. So the pattern here is the y values decrease by 2. That's all. Okay, I'm going to sketch this one. Now, remember, this was my gradient. Okay, so m equals minus 2. I'm going to make it into over 1 so that it looks like rise over run. And my y-intercept is 4. So when I sketch this, let me see if I could do 5, 4, 2, 3. Now, I know that plus 4 is my y-intercept. So I'm going to do here. It has to go through there, right? Because it's y-intercept. Now, always start from the y-intercept, put it in. Okay, so I think it's important you do y-intercept first on the graphing. And then my gradient is, this is going to it's a rise of a run, right? So that's my rise, which is my y values. And then run is the x's. So here I'm going to the right by 1. Okay, I'm going to by 1. And here, that is telling me going down by 2. Okay, if it was a plus, you're going up by 2, but it's going down by 2. So I'm going to go down by 2 here. 1, 2. That's where it's going to be. And then I will join them together. I don't have a ruler here. So, but one more thing. 3. First, I'm looking for the y-intercept. Second, I'm looking for the gradient. Now, what will help me more is if I could find the x-intercept. Now, you can't just find the x-intercept from the equation here straight away because there isn't. Now, x-intercept meaning is y equals 0. We're looking for something that is on the x-axis. So when something is on the x-axis, y has to be 0. So what I'm going to do is I'm going to substitute y equals 0 onto our function here. So it'll be 0 equals minus 2x plus 4. And I'm going to find the x value. So I'm going to move this to here to make it positive. So it's going to be 2x equals 4. And I divided that by 2. It'll be 2. Okay? Because 4 over 2 is 2. So I know my x-intercept is on 2 here. So then I could actually sketch it, join them together, straight line, not like what I've done. And when you do that, it'll be like this. And again, this is what we did, didn't we? We went to the right by 1, down by 2. So make sure you have that. And also, here it is, our x-intercept. X-intercept is when y equals 0. Just remember that. Okay, so we really need 3 points, don't we? So that's my y-intercept, that was my gradient, and that's my x-intercept. And then we join them together. Now, with gradient, we have positive gradient and negative gradient. Now this going up to the right-hand side, isn't it? That's your right-hand side part, is the positive. Okay? The positive is when gradient goes to the right-hand side. Now, think of this as going down from left-hand side. It's going to the direction of the left-hand side is a negative. Okay? So think of that as your little trick skill to remembering things. Okay, example 3. We're going to get straight into the graphing now. After the finding a gradient on y-intercept, sketch it. But we can do better than that. We're going to find one more, right? We're going to do one more, which is our x-intercept. I'm going to do x-intercept as well. So here, first, we need our y-intercept. That's where we're going to start sketching it. So y-intercept from this linear function is 1. Okay? And then my gradient, I'm going to put it as a little m, is 2, but I'm going to call it as a 2 over 1 because rise over run. 3, x-intercept, okay, when y equals 0 will be, I'm going to put 0 equals 2x plus 1. So I'm going to swap the position because I want x to be on my left-hand side. And I'm going to do minus 1 on both sides. And x equals minus. Now that just means minus 0.5. So let's see. Let's say 3, 2, 1, 0, minus 1, minus 2. And then 1, 2, 3, 4, minus 1, minus 2. Hopefully that's enough. I'm going to start with when y equals 1 here. Okay? And then going to the right, we're doing this first, going to the right, okay? Going to the right by 1. And this is a positive. It's going up by 2. And what was my x-intercept? Minus 0. Right there. That'll be minus 0.5. So if I join them together, make it a linear straight line, it'll look like this. Okay, so we've done the 1, remember, the y-intercept, and then we went 1 to the right, gone up by 2, and that's our second line, and that's right there is our x-intercept, which is minus 0.5, and join them together. And this is positive gradient, right? Because it's going to the right-hand side, towards the right-hand side, so it's going to be positive. I know this is nothing to do with the question, but I just want to show you that positive gradient. Okay, so that's a positive gradient. So I have y equals minus 4x. Now, because there's nothing at the end, I'm just going to put 0 there. That means, what's my y-intercept? Is 0. Okay, it's on the origin. Second, my gradient, little m, is minus 4 over 1. I'm just going to make it into rise over run form. And then I'm going to make x-intercept when y equals 0. So let's have a look. 0 equals minus 4x. And obviously, anything equal to 0, one of them has to be 0, isn't it? Minus 4 is not 0, so this has to be 0. So x equals 0. Okay, so that's okay. Now, let's have a look. 4, 3, 2, 1. My y-intercept is 0, so it's going to be on origin here. And it goes to the right by 1. You know what I've done? I made a mistake. I was being very careful, but I didn't. I have to go down by -4. So I need a bit longer down here. So I'm going to go from here. -4, -3, -2. Now I should be okay. So my y-intercept is 0, and I'm going to the right by 1, and then I'm going down by 4. So 1, 2, 3, 4, right there. And then my x-intercept is also 0, so it doesn't really matter. So I'm going to join these 2 points. It'll be something like this. Okay, so that's what we did, didn't we? So if you look at that, is we went 1 right and 4 down. Last one. So I'm going to have my y-intercept is -4. So it's going to start from -4. And then my gradient is 2/3. Now it's already in the rise over run form, so I don't have to worry about it. And my x-intercept is when y equals 0. So I'm going to put 0 equals, I'm using this right now, so 2/3 x -4. So I'm going to make x the subject, but I'm going to swap this because I want x to be on my left-hand side. So if you want, you can do it like this if you want. And then +4 on both sides. And I'm going to times by 3/2. So if you want to make this part 1, you just times by the reciprocal. Okay, so when you do that, you will get x. On your right hand side, it'll be 3/2. And you put that in your calculator, you will get 6. Okay, so I've got that, and let's have a look. 2 -4. Okay, so 1, 2, 3. So when I start from here, -4. So I start from, that's my y-axis. And remember, this is to the right. It's always to the right, right by 3. So I'm going to go 1, 2, 3. And I'm going up by 2. 1, 2, right there. And what's my x-intercept? Is 6. So I'm going to go to 6 right there. So we had 3 dots, and join them together, you will get something like this right there. Okay, so as you can see, we went to 3, 2, 3, and gone up by 2. All right, so and then you join them. So in a nutshell, you just have to, if you have to sketch any linear function, first step is y-intercept. Do we need to calculate y-intercept? Not really, because it's right there. It's given to us. That's our y-intercept. And your gradient is the coefficient of x. Number in front of x is your gradient. And make sure you write it in a rise over run format, so it's easier to, sketch it. And this is an extra bit, but I think it's important to know, and then for the accuracy. So practice this to find the x-intercept, putting y equals 0. So put here y equals 0 to find the x value. So your x-intercept is 6 here. And then you plot them and join them together. Okay, well, that's all that is for today's lesson. Well, thank you very much. We'll see you next time.